Hi everyone, and you are welcome to Copy in OOP lecture. Before I start, let me ask you a question. Let me assume that I have defined an object from a class and its name object1. After that, I define another variable object2 and I assigned the first object to object2. Now, what will happen to object2 if I update the value of object1? Are you confused? So, if you are unsure about the value of object2 after I have updated object1, join me in this lecture. In this lecture, I'm going to talk about the copy concept in Python object-oriented programming. First of all, I will start by defining what shallow copy is, then we will talk about deep copy, then we will learn about identity operator, which will help me to differentiate between shallow copy and deep copy, and I'll end up this lecture by a quick summary. So let's get started. First of all, let's start talking about shallow copy. In order to understand the idea, let me assume that I have a class, its name dummy class. From this class, I will define first an object, its name object1, and then I'll define another object which is object2 equal to object1. In this case, what happened in Python is the following. Object2 will be a reference to the same location that object1 refers to. In other words, object2 is not a standalone object. Object2 is just a reference to the same location. And from this we can understand that using just assignment operator will create a reference to the same location in the memory. So if I change the value of object1, the value of object2 will change also. And if I change the value of object2, the value of object1 will be changed also. So be careful from this point, because sometimes you could assume that when you assign one object to another, you have created a standalone object copy. But this is not the case in Python. I'm sure right now that the question that's in your mind is how I can create a standalone copy. In other words, if I change this copy value, the original copy will not be changed. The answer to this question comes from deep copy. So again, let me assume that I have a class, its name dummy class. I'll define an object from this class, object1 equal to dummy class. Now, in order to create what we call a deep copy or an actual real copy from the object, we have to use copy module in Python. So I'll import copy in order to use the function deep copy, which will help me to create a deep copy from that object. In this case, I'll say object2 equal not to object1, but to copy.deepCopy object1. And that means now object2 is a standalone copy. In order to understand the idea better, this simple diagram will show you that now object1 refers to memory location 1 and object2 refers to memory location 2. Memory location 2 is different from memory location 1. And from this we understand that if I update object1, object2 will not be affected, and if I update object2, object1 will not be affected, and in this case we have a real copy for the object1. Now let's say that you have a complex script and you have two different objects in this script, object1 and object2, and you are not sure if object2 is a shallow copy or deep copy to object1. So how you can be 100% sure about what is the status of both objects? Very simple. You have to use in this case identity operator. So the keyword that represents this operator in Python is. So what this operator does is very simple. Actually, usually we use this operator to compare between two variables. And usually we are not checking if they are equal from value perspective, but we are checking if they are referring to the same memory location. What that means, if this operator gives me true, this means object1 is a shallow copy of object2 and object2 is a shallow copy of object1. And vice versa, which means deep copy if the value is false. To understand this operator better, let me show you the following table. This operator takes two operands, which means it will compare one object to another, so it takes two operands. The data type of these operands is object, so objects of any class can be compared using this identity operator. And once you use this operator, the final result data type is going to be number, which is a Boolean number. Why I say Boolean? Because this operator will give me an answer, true or false. True for shallow copy and false for deep copy. Now let's move to Jupyter Notebook in order to see some example about shallow copy, deep copy, and identity operator. Okay. In order to understand the difference between shallow copy and deep copy, first of all I need a class and some objects. So for this purpose, I'm going to create this dummy class, and as you see, it has only one instance attribute, which is dummy value. And I will run to make sure that this class is defined. Then let's create some objects. So I'll say object1 equal to dummy class and object2 equal to object1. As we have seen, this is just a shallow copy, but let's verify that. So I'll change now, or sorry, before I change, I will print before. So I'll print the value of object1 dot dummy value and object1, or sorry, object2 dot dummy value. After this step, I will make one change to object1. So I will get access to this dummy value here using dot operator, and I will give the value of 10. Now let me print after. And I mean by after here, before update and after the update. So let's see. So before the update, when I access to dummy value of object1 and when I access dummy value to object2, I get in both cases 5 and 5. After that, as you see here, I am only changing the dummy value of object1, not for both objects. But even though when I print the dummy value for both objects, I get, as you see here, 10 and 10. And from this, we can understand that both object1 and object2 are just shallow copies, which mean one is a reference to the same memory location that the second one refers to. Now, let's take this code and now let's create, instead of shallow copy, a deep copy. So let's see how we can do that. So I'll copy and paste this. And in order to create a deep copy, you have to import copy module. And from this copy module here, instead of saying object2 equal to object1, I'll say copy.deepCopy object1. So look here, it's not a direct assignment, whereas it's creating a deep copy. If I run, look here, before I have 5, 5. After that, I have updated only object1. So when I print after, only the value of object1 has been changed, whereas the value of object2 is exactly the same without any change. And from this, we can understand now that object2 is a deep copy of object1, which means they are referring to two different locations inside the memory. Now let's see how identity operator works. So I'll take these two objects again here. Let me delete here some spaces. Object1 equal to dummy class object2, it's a deep copy. So if I say print object1 is object2, and here if I put just some dummy print statement and run, you will see here the result is false. Why we have false? Because object1 is a deep copy of object2 and object2 is a deep copy of object1, which means they are referring to two different locations. For this reason, is will give me false. Now let me create a shallow copy and run. You will see in this case the result is true, because now both object1 and object2 refer to the same location in the memory. And this is quite important to understand. So is will help you to discriminate between shallow copies and deep copies. And that's all for this code session. Thank you. Now let's recap what we have learned in this lecture. First of all, I have talked about shallow copy. And we see that in shallow copy, when I assign one object to another, I just create a reference to the same object in the memory. Whereas in deep copy, when I assign one object to another, I am creating a new object equal to the other object, but it's a standalone copy inside the memory. Changing one will not affect the other. And finally, we have talked about identity operator, which I usually use to know if one object is a shallow copy or deep copy of another object. Now please, I want you to refer to the lecture resources in order to find some challenges to practice what you have learned so far in this lecture. Thank you very much for your time, and if you are available, join me in the next lecture.